All right, so in this video, we're going to go over those recommended practice problems from lesson 6, which was the theorems. Those problems were on page 210, 3C, 3E, 3G, and 3I. So let's go ahead and get to it. The first problem was 3C. This was derive if A, then if B, then A and B. So as we recommend in the strategies document, which hopefully you've looked at, what we're looking at here is a material conditional as the main connective. So starting that subderivation, we're going to assume the antecedent, A, as a premise for conditional introduction. Now when we look at that consequent, we've got another material conditional, right? So what we're going to do is assume B as a premise for conditional introduction again. So here we're nesting derivations. Now the consequent here we need to get is A and B. This is really easy, right? We have A on line 1, B on line 2. So we can get A and B from conjunction introduction from lines 1 and 2. And then we just need to start working our way out, right? For this second conditional, we wanted B, and then we got A and B. So we can get if B, then A and B from conditional introduction on lines 2 through 3. And now we wanted if A, then if B, then A and B. So we can come all the way back to the main scope line with that entire theorem, right? That entire conclusion we're trying to get. And this time we, again, are using conditional introduction, and we're citing the whole subderivation, so lines 1 through 4. This one's a pretty straightforward example. Okay, on to the second problem. We're trying to derive if A, if and only if B, then if A, then B. So again, we're looking at a material conditional here as our main connective. So we're going to assume that entire antecedent, right? A, if and only if B. Now our consequent here is also a material conditional. So just like the last problem, we're going to do another subderivation nested inside there where we assume the antecedent to try to get that consequent. And now we have A, if and only if B on line 1 and A on line 2. So again, this one's pretty easy. We can get B by biconditional elimination from lines 1 and 2. And then we can work our way out, right? We can move back to that second scope line on line 4 and have if A, then B via conditional introduction for that subderivation lines 2 through 3. Then we can step the rest of the way out and have back to the main scope line and have if A, if and only if B, then if A, then B via conditional introduction from lines 1 through 4. So here's the last problem we were looking at. This one's a little bit longer, right? We're trying to derive that if A, then B, if A, then B, then if C, then A, then if C, then B. So this one's a little bit confusing to even articulate, but we're going to take the same strategy, right? Our main connective here, the connective that's not in any parentheses, is a material conditional. So we're going to assume that whole antecedent, if A, then B. So now looking at that consequent, our main connective here is also a material conditional, right? This is what these problems have in common. So we're going to assume the entire antecedent for that conditional, right? Which in this case is if C, then A. And now looking in, the consequent that we're trying to get for this conditional is also a material conditional, right? If C, then B. So we need one more subderivation where we assume C as a premise for conditional introduction. So here we've got 3 nested subderivations. So now we've got to work with these to try to get B. We've got if C, then A on line 2 and C on line 3. So we can get A by conditional elimination from lines 2 and 3. And now that we have A by itself on line 4, we can get B using conditional elimination, again, using line 1 and A by itself on line 4. So now we've proven if C, then B. So we can get that out via conditional introduction, lines 3 through 5. Stepping out once more, we can get if C, then A, then if C, then B. Again, conditional introduction, this time lines 2 through 6, right? This entire second subderivation. And now that we've proven what we want is the consequent for our main theorem from what we want is the antecedent, we can go all the way back out to the main scope line and have the whole sentence we're trying to prove, right? Our whole theorem here. So that's this problem. Again, it's very similar to the last two problems, but adding a couple more steps. The purpose of reviewing these problems is to help you kind of internalize these strategies for proving theorems. Our last one here is if A then B and not B, then not A. So we're going to do the same thing, right? We're going to assume the whole antecedent for our main material conditional. So we have if A then B and not B. And now we need to prove the negation of A. So what I'm going to do here is assume the opposite of the negation of A, which is just A by itself, as a premise for negation introduction, right? Because we're trying to get A with that negation attached. So we assume it without the negation for negation introduction. Now we can start breaking this apart, right? We can get if A then B from conjunction elimination from line 1, which then lets us get B by itself from lines 2 and 3, right? We have A and we have if A then B, so we can get that consequent B on line 4. And now we can get not B, right? We can get our contradiction also via conjunction elimination from 1, where we had not B as one of those conjuncts. So we assumed A and proved a contradiction, so we can go back one scope line and get the negation of A. We can add that negation on via negation introduction from lines 2 through 5, that whole subderivation. So now looking back at our first whole subderivation, right, we assumed if A then B and not B, and we proved not A, right, we proved that negation of A. So we can go back to the main scope line and introduce that material conditional with our antecedent and our consequent, and there's that whole theorem we were trying to prove. So all of these theorems took a very similar strategy. There are other strategies you can do with theorems, such as assuming the opposite and things like that. We will do some more theorem problems once we get to the SD plus rules. The SD plus rules make a lot of this much, much easier. So that's it for this review video. I'm going to make another review video here in a couple of minutes going over some SD plus problems because that's the next portion of this lesson.